Clastic sedimentary rocks definition. Clastic sedimentary rocks are a class of sedimentary rocks that are formed from the accumulation, compaction, and cementation of fragments of pre-existing rocks or minerals. These rocks are composed of clasts, which are individual pieces or particles of various sizes and shapes, ranging from microscopic clay particles to larger pebbles, cobbles, and even boulders. The term clastic is derived from the Greek word klastos, meaning broken, which aptly describes the origin of these rocks through the fragmentation and reassembly of pre-existing materials. The process of formation begins with the weathering and erosion of parent rocks exposed at the Earth's surface. This can occur through physical, chemical, or biological processes, such as frost action, abrasion by wind or water, dissolution by acidic fluids, or the breakdown of rocks by plant roots and organisms. These processes gradually break down the parent rocks into smaller fragments, which are then transported by agents such as rivers, streams, glaciers, wind, or gravity. During transportation, the clasts undergo sorting and rounding, with finer particles traveling farther and being deposited farther from the source, while coarser particles settle closer to the point of origin. This sorting and rounding are influenced by factors such as the velocity and turbulence of the transporting medium. For instance, fast-flowing water tends to sort and round particles more efficiently than slow-moving water. Once the clasts reach a point of deposition, such as a river delta, beach, or deep ocean basin, they settle out of the transporting medium due to a decrease in energy. Over time, these accumulated clasts undergo compaction under the weight of overlying sediment layers, which reduces the pore space between them. Concurrently, mineral-rich groundwater percolates through the sediment, depositing cementing minerals, such as calcite, silica, or iron oxide, which bind the clasts together, forming a solid rock matrix. The resulting clastic sedimentary rocks exhibit a wide range of characteristics depending on the size, shape, sorting, and composition of the clasts, as well as the type and abundance of cementing minerals. Common examples of clastic sedimentary rocks include sandstone, conglomerate, shale, siltstone, and breccia, each with distinct properties reflecting their depositional environment and history. These rocks serve as valuable records of past geological processes and environments, providing insights into Earth's history, including ancient landscapes, climates, and ecosystems. Formation of clastic sedimentary rocks. The formation of clastic sedimentary rocks is a complex process that involves several stages, beginning with the weathering and erosion of pre-existing rocks and culminating in the lithification of sediment into solid rock. This process can be broken down into several key steps. Weathering. Weathering refers to the physical, chemical, and biological processes that break down rocks at or near the Earth's surface. Physical weathering involves the mechanical breakdown of rocks into smaller fragments through processes such as frost action, thermal expansion and contraction, abrasion by wind or water, and the activities of organisms like plant roots. Chemical weathering involves the alteration of rock minerals through chemical reactions with water, atmospheric gases, or organic acids produced by living organisms. Biological weathering occurs when organisms such as plants, bacteria, or burrowing animals contribute to rock breakdown. Erosion and transport. Once rocks are weathered into smaller particles or clasts, they are transported away from their source by various agents such as water, wind, ice, or gravity. The transportation process involves the movement of sediment particles downstream or downslope, where they are sorted and transported according to their size, shape, and density. During transportation, finer particles may be carried farther from the source due to their lighter weight and greater susceptibility to being suspended in fluid mediums, while coarser particles tend to settle closer to the source. Deposition. As the transporting medium loses energy, usually due to a decrease in velocity or turbulence, sediment particles settle out of suspension and accumulate in layers at a new location. This process of deposition occurs in depositional environments such as river deltas, beaches, floodplains, alluvial fans, deltas, lakes, or deep ocean basins. The characteristics of the deposited sediment, including grain size, sorting, and layering, are influenced by factors such as the energy of the transporting medium, the distance from the source, and the nature of the depositional environment. Compaction. Over time, the weight of overlying sediment layers exerts pressure on the deposited sediment, compacting it and reducing the pore space between particles. Compaction occurs gradually as additional layers of sediment accumulate above, increasing the vertical pressure on the underlying layers. This pressure causes the sediment grains to rearrange and become more tightly packed, expelling water and air from the pore spaces between grains. Cementation. As compaction proceeds, mineral-rich groundwater percolates through the compacted sediment, depositing cementing minerals in the pore spaces between grains. Common cementing minerals include calcite, calcium carbonate, silica, silicon dioxide, iron oxide, hematite or limonite, and clay minerals. These cementing minerals act as a binding agent, adhering the sediment grains together and transforming the loose sediment into solid rock. Lithification. The final stage in the formation of clastic sedimentary rocks is lithification, where the compacted and cemented sediment is transformed into solid rock. This process involves the consolidation of sedimentary particles into a coherent mass through the combined effects of compaction and cementation. Over time, the sedimentary rock becomes lithified, preserving the characteristics of the original sediment, including grain size, sorting, layering, and mineral composition. Classification of clastic sedimentary rocks. The classification of clastic sedimentary rocks is based primarily on the size, shape, sorting, and composition of the clasts, sediment particles, present within the rock, as well as the nature of the cementing minerals. Clastic sedimentary rocks can be broadly categorized into three main groups: conglomerates, sandstones, and mudrocks. Within each group, there are various subtypes that reflect specific characteristics and depositional environments. Let's explore each category in more detail. Conglomerates and breccias. Conglomerates are composed of rounded clasts larger than 2 mm in diameter, typically ranging from pebble to boulder size. These clasts are usually well-rounded due to the abrasion they undergo during transportation. Breccias, on the other hand, are characterized by angular clasts larger than 2 mm that are poorly rounded and often have sharp, angular edges. They form in environments where the clasts have undergone minimal transport and remain relatively close to their source. Conglomerates and breccias are commonly associated with high-energy depositional environments such as alluvial fans, braided rivers, and nearshore marine environments. Sandstones. Sandstones are composed predominantly of sand-sized clasts, which range in diameter from 1/16 to 2 mm. These clasts can be either rounded or angular, depending on the degree of transportation and weathering. Sandstones are further classified based on their composition and texture. For example, quartz sandstones are dominated by quartz grains, whereas lithic sandstones contain significant amounts of rock fragments. Arcosic sandstones are rich in feldspar grains. Sandstones are commonly found in a variety of depositional settings, including beaches, river channels, dunes, and shallow marine environments. Mudrocks. Mudrocks are composed predominantly of silt and clay-sized particles, with clasts smaller than 1/16 mm in diameter. These fine-grained particles are commonly referred to as mud or mud-sized particles. Mudrocks encompass a range of rock types, including shale, siltstone, and claystone, depending on the proportion of silt and clay particles present and the degree of lithification. Shale is the most common type of mudrock and is characterized by its ability to split into thin layers, due to the orientation of clay minerals during compaction. Mudrocks typically form in low-energy environments such as deep marine basins, floodplains, and lakes, where fine-grained sediment settles out of suspension and accumulates slowly over time. In addition to these primary categories, there are various transitional and mixed clastic sedimentary rocks that exhibit characteristics of multiple categories. For example, lithic sandstones may contain a mixture of sand-sized quartz grains and lithic fragments, while sandy mudstones exhibit characteristics of both mudrocks and sandstones. Overall, The classification of clastic sedimentary rocks provides valuable insights into the depositional history, environmental conditions, and sedimentary processes that shape the Earth's surface over geological time scales. Clastic sedimentary rocks examples. Clastic sedimentary rocks encompass a diverse array of rock types, each characterized by the specific size, shape, sorting, and composition of its clastic particles, as well as the nature of its cementing minerals. Here, we delve into various examples of clastic sedimentary rocks, highlighting their unique characteristics and depositional environments. Sandstone. Sandstone is one of the most common clastic sedimentary rocks and is composed predominantly of sand-sized grains, 1/16 to 2 mm in diameter. These grains are typically composed of quartz, feldspar, lithic fragments, or a combination thereof. Sandstones vary widely in color, texture, and composition depending on the minerals present and the depositional environment. Quartz sandstone, dominated by quartz grains, often with well-rounded, translucent grains. Commonly found in beach environments, dunes, and shallow marine settings. Arkose, characterized by abundant feldspar grains, giving it a pinkish to reddish color. Often associated with continental environments such as alluvial fans and desert basins. Lithic sandstone contains significant proportions of lithic fragments, rock fragments, resulting in a varied composition. Lithic sandstones are commonly found in areas with abundant sedimentary or volcanic source rocks. Conglomerate. Conglomerates consist of rounded clasts larger than 2 mm in diameter, cemented together by finer-grained matrix material. These clasts range in size from pebbles to boulders and are typically well-rounded due to the abrasion they undergo during transportation. Quartz conglomerate, composed predominantly of quartz clasts, often found in high-energy environments such as alluvial fans and braided river systems. Polymicte conglomerate, contains a diverse mixture of clasts derived from different rock types, reflecting a complex depositional history with multiple sediment sources. Shale. Shale is a fine-grained clastic sedimentary rock composed primarily of clay and silt-sized particles, 1/16 mm in diameter. It typically exhibits facility, meaning it can be easily split into thin layers or sheets due to the alignment of clay minerals during compaction. Claystone consists predominantly of clay-sized particles, resulting in a smooth, homogeneous texture. Claystones are commonly associated with low-energy depositional environments such as lakes, floodplains, and deep marine basins. Siltstone contains a higher proportion of silt-sized particles compared to claystone, imparting a slightly coarser texture. Siltstones often occur in environments with moderate energy levels, such as river floodplains and deltaic settings. Mudstone. Mudstone is a general term used to describe fine-grained clastic sedimentary rocks that are similar in composition to shale but lack the facility characteristic of shale. Mudstone encompasses a range of rock types, including silty mudstone and sandy mudstone, depending on the proportions of silt and sand-sized particles present. Breccia. Breccia is composed of angular clasts larger than 2 mm in diameter, cemented together in a finer-grained matrix. Unlike conglomerates, breccias contain angular clasts that are poorly rounded, suggesting minimal transport distance from their source. Breccias commonly form in settings such as fault zones, landslides, and near the base of steep cliffs or mountain slopes. These examples illustrate the diverse range of clastic sedimentary rocks and the variety of depositional environments in which they form. Each rock type provides valuable insights into past geological processes, including erosion, transportation, deposition, and lithification, contributing to our understanding of Earth's dynamic surface environments over time.